Aha. Here's an IGCSE question. The diagram shows the positions of 3 cities: Geneva, labeled G; Budapest, labeled B; and Hamburg, labeled H. So the question says, because the diagram is given, that's typical of IGCSE, they will have given us the diagram in most cases, and that simplifies the question. Okay, so the first part of the question says, a plane flies Hamburg, Geneva to Hamburg. The flight takes 2 hours 20 minutes. Calculate the average speed in kilometers per hour. When we have, of course, this question, the first part of the question is not a typical bearing question, so it's not part of bearing, average speed. But let's just look at it together. Let's just look at it. Of course, let's read through. We also have, using cosine rule, we are told what to use to calculate the distance from Geneva to Budapest and the bearing of Budapest from Hamburg, and to find the bearing of Hamburg from Budapest. So let's see how we go about the solution. I have a diagram of it here already. Alright, so we said the first part, like I said, is not a bearing question. The time here is, of course, let's use our average speed. The formula: average speed is equal to total distance okay, divided by total time. Total time taken. Okay, so having said that, let me first, we need to convert the unit. We need to convert the unit of time, because we can see 2 hours 20 minutes. So we want our speed in kilometers per hour. So that 2 hours 20 minutes is the same as 2 hours 20 minutes there is the same as 2 whole number. Of course, the 20 we divided by 60 to convert everything to hours. Of course, we have 2 whole number 1/3 hours, and that's basically is the same as 7/3. Let's keep it in fraction to avoid any loss by rounding. Okay, so this is what we have, and so we're going to plug that into our formula. Average speed is equal to total distance divided by total time. Okay, so that's our average speed will be the total distance from there is 864 divided by 7/3. Of course, basically you can say 864 times 3/7. 864 times 3/7. If you do that, we're going to get 370.3. As expected from IGCSE, usually if we are not given any degree of accuracy, we can keep our answer to 3 significant figures. So keeping this to 3 significant figures, we have 370 kilometers per hour. 370 kilometers per hour. That gives us the average speed there. That's the average speed. Let's go to, of course, we can write to 3. Let's write our degree of accuracy, 3 significant figures. Okay, so let's move on to the second part. Now in the next part, we're asked to calculate the distance from Geneva to Budapest using cosine rule. Of course, we've been told the formula to use. Alright, let's see how it goes. From G to B here, let's just label it H. So of course we can write the cosine formula as H squared equals to let me just substitute the values. 864 squared plus 928 squared minus 2 times 864 times 928 cos 67 degrees. Please note that this is just a continuation here. The one down here is just a continuation of what we have here. Okay, so let me just, this is just a continuation over there. Okay, so we have from that place we have taking the square of all these parts, 864 squared plus 928 squared. We have such a very long number there, 1607680. Okay, minus, then we compute 2 times 864 times 928 cos 67. Let's put it together once so we don't waste our time. We have 626570, let's say 0.19. we are not yet there yet, so I don't want to round. I'm very careful, like I've always said. Let's be careful of rounding when we are not yet in the final answer. Yeah, so having done that, let's subtract. Subtracting this, we have 981 and 109.81. Let me still be writing the decimal because I'm not yet there yet. I'm not yet there. So we got taking the square root of both sides. Take the square root of both sides. We have square root of 981,109.81, and doing that, we've got H is equal to punch that in the calculator. We have 990.5 kilometers. Please make sure you punch it in the calculator also, because sometimes we look at all these things like, oh, when I get my calculator I'm going to do it. It's so simple. Yeah, it's very simple actually, but you've got to try it yourself and confirm that you have the same answer. Of course, like I said, as typical of IGCSE, the requirement is 3 significant figures except you're told, unless you're told otherwise in that question. So here, rounding this to 3 significant figures, we got 991 kilometers, the distance from Geneva to Budapest. To 3 significant figures. 3 significant figures. Okay, so here is my answer there. Let's see the third part of the question. This time we are to calculate the bearing of Hamburg from Budapest. Note that we've been given the bearing of Budapest from Hamburg. That is, if we stay at Hamburg, turning from the north of Hamburg in this direction, we've got 133. Sorry, we've got 133 degrees. That's according to what we're given. We've been given that. Alright, now finding the bearing of Hamburg from Budapest. That means from the north here down here. That is the angle we want to find now. Oh, so can we first find this angle here? We can first find this angle here in this corner. That's 180 minus 133. 180 minus 133, that's simply 47 degrees. 47. All right. If you observe very well, you would take note that alternate angles this way, alternate angles like this, that tells us that this angle here is also 47 degrees. 47 degrees. Oh, that having been said, that means the required angle, the remaining angle all around the point, is just 360 minus 47. 360 minus 47. 360 minus 47 minus 47 degrees, and that is 313 degrees. That's the bearing, the required bearing. That's just the required bearing there. Finally, we have to calculate the bearing of Budapest from Geneva. Budapest from Geneva. B from G. That means as we stay on G, we turn around this way. So here's the angle we are looking for. Here's the angle we want to find now. We want to find that angle over there. Well, of course, you can look at it in many ways, of course, but I would advise that we should take alternate angle this way. Take alternate angle. So finding that is the same task as trying to find this angle here. It's trying to find this is the same as trying to find this alternate angle. So if we want to do that, I want to say that probably let's first get the angle here. Let's get the angle here. Let's call that angle alpha. And so we'll use our sine rule to get that. Let's use sine rule to get that, because looking at it, we already have this angle. We already have this line here as so we can say 8, using our sine rule, 864 divided by sine alpha equals to this other side here, which is 928 divided by 928. Sorry, we can't get that because we don't have this other angle here. We can't use that. Let me use what we have. We have this angle here to be 67, was given in the diagram, has been given 67. So we can say that we found this other side here. We found it from the beginning. That's 990.5. 990.5. Yes, that's how we do it. 990.5 divided by sine 67 degrees. Sine 67. Alright, so working with that, we can say that sine alpha equals to 864 sine 67 all divided by 990.5. We compute that. Or let's just write the answer all at once. Let's write the answer at once. We can have that sine alpha itself is equal to taking the inverse of sine inverse of all this. Here we've got that alpha will be equal to 53. Make sure you try it and get it yourself. 53.4 degrees. 53.4. So having done that, we can simply say that the required angle, the required bearing, which is this part down here, is 47 is 47. Let's just 180 degrees. Of course, this is a straight line down on the left side. 180 minus sum of 47 up there, 47 degrees up there, plus the one we just found now, that's 53.4. If we do that together, we should get our angle, our final answer, to be equal to 079. Probably you can add 0.6 degrees. That is the required bearing, the bearing of Budapest from Geneva.